Hello Committee, Director Dr. Perfecto Malaquías Quintero Flores, Co-Director Dr. Rodolfo Lezar Perez Loaiza, Reviewer Dr. Jose Crispin Hernandez Hernandez, and my tutor Maria Hanay Sanchez Hernandez. I am Armando Rocha Cedillo, and in this video I will talk about the Avance in the Seminario subject. Well, first of all, my subject name is Data Science and Natural Language Processing Techniques Applied to Tweets to Obtain News About the Pandemic. The description of the problem is that the rapid growth of volume tweets and their analysis pose major challenge. The data in the flow process cannot be stored. In addition, we cannot efficiently process such data more than once. Twitter is one of the platforms from which it generates a lot of information. Nowadays, for the situation that crosses on humanity, there is a lot of false information about the pandemic. This kind of false information came from bots or people who want to follow some links to steal information. The research question is it possible to apply analysis and data science to analyze and detect truthful information about the pandemic, and how to apply fuzzy logic to determining the rank of tweet is true? Well, the objective is design and implement a model that allow the processing, analysis, and display of the most relevant between fake and true tweets about the pandemic, using techniques that are flow meaning tools, natural language processing techniques, and fuzzy logic. Justification: the benefits of being able to design a model that can recapture data from package, process them, and generate knowledge. This will help to society to know the most often tweets focus to give false information or news in order to other kind of purpose than is to inform. Big data and understanding the nature of the human. Well, as I said, massive data growth. If we add to all these financial transactions made only or by mobile device, social network analysis on Twitter, there are about 12 terabytes of tweets created daily, and Facebook stores around 100 petabytes of photos and videos. Geographical location using GPS coordinates, in other words, all those activities that most of us carry out several times a day with our smartphones. We're talking about the fact that around 2.5 quintillion bytes are generated daily in the world. Well, the state of the art is that I'm going to describe three related words by how to get input, stream, and classify, and some important subjects. Well, the classifier system, the most common are naive Bayes, that is a probabilistic. This classifying inspired by the Bayes theorem under a simple assumption, which is the attributes are conditionally independent. The artificial neural network is a set of connected input-output units where each connection has a weight association with it, started by physiologists and neurobiologists to develop and test computationally analogs of neurons. Decision trees builds classification or regression models in the form of a tree structure. It utilizes an if-then rule set which is mutually exclusive and exhaustive for classification. Neurofuzzy hybridization result is an hybrid intelligence system that synergizes this two techniques by combining the human-like reasoning style of fuzzy system with the learning and connectionist structure of neural networks. The next subject is related work. In this related work, there are three works that explain the way they classify tweets for different purposes, such as download lots of tweets without bottleneck issues, and so on. The first is sarcastic sentiment detection on tweets. They work around the way to catch Twitter streaming. They use 5 sets of tweets crawled from the Twitter using the Twitter streaming API and processed through Flume before being stored in the HDFS. The second is about the Twitter stream data mine system. Here they use the machines of support vectors to establish as a better classification with maximum precision and minimum squared error in this project. Also, they build a web application. And the last, they propose a dense classifier with contextual representation and embedded in language model to classify crisis-related data on social media during a disaster. The traditional classifier support vector machine and the deep learning classifier convolutional neural red and convolutional neural red multilayer were used. The next subject is natural language processing. Natural language processing is important for scientific, economic, social, and cultural reasons, and it is experiencing rapid growth as its theories and methods are implemented in a variety of new language technologies. Natural language processing makes it possible for computers to read text, listen to the spoken voice, interpret it, measure sentiment, and determine which parts are important. Lexical features play a vital role in detecting double meaning in text. Using these lexical features together with syntactic features helps to detect ambiguities and have a better understanding. Here we have some important concepts. The first, name entity recognition, refers to the identification of words in a sentence as an entity, like the name of a person, place, organization, and so on. Chunking is a process of meaningful extracting short phrase from the sentence. Here chunking is helped by tagged with post tag. Stemming is an algorithm worked by cutting off the end or the beginning of the word, taking into account a list of common prefix and suffix that can be found in an inflected word. This indiscriminate cutting can be successful in some cases. The next subject is post tag. Post tag is parts of a speech. This divides sentence or paragraphs into words and assigning corresponding parts of a speech information to each word based on their relationship with adjacent and related words in a phrase, sentence, or paragraph. Parts of a speech tagging simply refers to assign parts of other words. Well, post tag is important because from here we can structure the sentence from tweets. The next subject is extract data from Twitter. As we can see here, we have 5 tools that will help us to extract the large size of a database. In this case, it's Twitter, to be able to work with them with this data. So, as we can see, TweetP is easy to use in Python, and Twitter 4G is easy to use for Java. Both are downloaded for downloaded limit for Twitter. Apache Flume handles small large amounts of logs data, and Apache Kafka is great at handling large volumes of data. Well, Apache Flume is a distributed system for efficiently collecting, aggregating, and moving large amounts of data. Flume has a source and sink architecture. A Flume source collects the event data from the data source. A Flume sink puts the event into an external repository, which is often a streaming system like Apache Kafka or another. Apache Kafka is great at handling large volume of data. You can set up a cluster as a data backup one, which gives you great scalability. You can then easily expand the cluster as needed without downtime. And Apache Spark is a computing system that is based on hand-up, map, reduce, and mainly allows to divide or parallelize the work, since it is normally installed in a machine cluster. Well, the next subject is input data to Spark. Here we have a little image where we can see how Kafka and Flume are used as a mechanism to ingest data into Hadoop. This data will be the tweets and will introduce to the Spark. In other words, we can catch the data stream of tweets with Flume to introduce to Spark. Then this led us to treat both batch and streaming data as a table. Since tables and data frames datasets are semantically synonymous, the same batch-like data frame dataset queries can be applied to both batch and streaming data. Well, the next subject is fuzzy logic. The ability of humans to handle vague and imprecise data make such tasks easier for us. Fuzzy logic is a methodology that provides a simple and elegant way to draw a conclusion from vague, ambiguous, imprecise, noisy, or incomplete input information. In general, fuzzy logic mimics how a person makes information-based decisions with a specific characteristic. Fuzzy logic is a generalization of standard logic, in which a concept can possess a degree of truth anywhere between 0 and 1. Standard logic applies only to concepts that are completely true, having degree of true 1, or completely false, having the degree of true 0. Well, the proposal and methodology. I propose a fuzzy inference system. Therefore, if the goal is to get unstructured information from tweets, we must be able to model the fuzzy inference system. The model must be built in such a way that it is capable of handling information, sharing location tags, and sharing a knowledge base to begin finding. First, I have to use fuzzification, which is the process of converting a sharp input value into a fuzzy value that is done by using the information in the knowledge base. The input value comes from tweets that are stored in a Spark. So then the information in the knowledge is some fake tweets. For the fuzzification process, the Gaussian, triangular, and trapezoidal membership function are the most widely used. Membership functions are mathematically defined with various parameters to adjust the performance of a fuzzy logic function. These parameters or the shape of the membership can be adapted. We can apply two types of rules that are fuzzy pattern tree that work such a decision tree but apply membership grades, and the other one is fuzzy rule system that choose the fuzzy input X and outputs Y, then define the universal set and a fuzzy set, and define the linguistic variable and their members function. Here apply if-then rules. Also, we can include a FRBCS, that is the internal function that implements the fuzzy rule base. Is made up of two elements, the inference system and the knowledge base. Well, we will have this workflow. So if we put everything together, we can work for the input, streaming, Flume, or Kafka to introduce the data to Spark. Then process the data applying the fuzzy inference system to classify false and true tweets. And the last, I have built the working plane, and for the last I show my working plane from begin date to end date. And here we have the reference, and it's. Thank you for watching.